Hi, once again, it's your man Chiefs. Back to our physics lesson. We're looking today at electrostatics. You'd remember earlier on, maybe in primary school, when you talked about electrostatics, about removing a jersey, and you hear sparks when you're removing a jersey, or when you used a ruler to rub your head, and you put it over pieces of paper, and there was electrostatics. Now we're doing calculations that are involving electrostatics. Most of the things in science involve a particular law. Electrostatics involves what we call Coulomb's law. Coulomb's law states that the magnitude of the electrostatic force exerted by one point charge, Q1, on another point charge, Q2, is directly proportional to the product of the magnitude of the charges and inversely proportional to the square of the distance between them. In your exam paper, you'd find at the end of your exam paper, at the back of the exam paper, there will be formulas on electrostatics, and one of them states that F is equal to K multiplied by Q1 multiplied by Q2 over R squared. Now, it is very important for you to understand what each aspect of this equation represents. The F represents the electrostatic force, all right? So your F is representing the electrostatic force. And this electrostatic force is in newtons. Now you understand that force is a vector quantity, all right? So at the end of the question, we must give direction to the answer. The next one is K, which is called the Coulomb's constant. The value of the Coulomb's constant is also found at the back of your exam paper, and Coulomb's constant is equal to 9,0 times 10 to the power of 9 Newton, right, meters per Coulomb squared. Okay, the next one, charge 1 and charge 2 are charges, and as you know, charges are measured in coulombs, right? Also interesting is we have got R, which is the distance, all right? Here it's squared. Remember when we looked at some relationship that looks like this, which is Newton's law universal of gravitation, we said the relationship between F and R is an inverse square. And how, if you would double the R, what would happen to F? The same questions are common when you're looking at Coulomb's law. Please remember that. If you've forgotten, go back to the video on Newton's law of universal gravitation and revise the question we did on changing the different parameters. So the Q1 and the Q2 are directly proportional to F, but the R is inversely proportional to the force. So your R is in meters, that's the distance between them, and that distance is in meters. All right, so that's the formula that gives us an understanding of Coulomb's law. You must have done this at certain points in your study, and this is just a mere revision and introduction of our work on electrostatics. Now, let's look at an example, a quick example on a question on electrostatics that you might find in an exam. Two spheres Q1 and Q2 are 50 centimeters apart. The charge on Q1 is 3 times 10 to the power 6 coulombs, and the charge on Q2 is minus 4 times 10 to the power negative 6 coulombs. Calculate the electrostatic force between the charges and state the nature of the force. All right? When we are talking about the nature of the force, we are asking, is it an attractive force or is it a repulsive force? Now what happens basically is we know that charges can be positive or negative. We'll look at the diagrams that represent the different charges when we talk about electric field. A positive charge and the electric field around it, a negative charge and the electric field around it. And we know that positive and positive would repel, and positive and negative would attract. Negative and negative would repel. All right. Now, as you always know, before I delve much into the information that I have for you, I get into the shop. I need to tell you about our textbook, Revolutionary Science Workbook Study Guide 1, which was written by Norman Muvoti and Timothy Sibeko. Please handle or get hold of this book, and the ISBN number is given right here. This is the book that I took that example from, and you can have more examples that will help you understand and calculate aspects of electrostatics. Now let's start with the question that's up on the board, and let's try to answer it. All right. So this example, let's call it example 1. It says that two spheres, Q1 and Q2, are 50 centimeters apart. So if that's the R, 50 centimeters apart, we know that the R should always be in meters. So instantly I must change that 50 centimeters to meters. So 50 to meters. How many centimeters are there in a meter? You can refer to your meter rule. There are 100 centimeters in a meter. All right. So that would be 0.5 meters, right? Not the final answer, but that's the distance between them. Now, let's use the formula to find the force, electric force F, or electrostatic force F, that exists between the charges is equal to K multiplied by Q1 multiplied by Q2, all divided by R squared. What did we say the value of K is? The Coulomb's constant. The Coulomb's constant is 9 times 10 to the power of 9 multiplied by, in this case, Q1, 3 times 10 to the power of negative 6 multiplied by, we don't put minus 4 because remember, we calculate the magnitude using the magnitude of the charges, all right? So we use the positive values only in our substitution so that we do not subtract, okay? 10 to the power negative 6 divided by the distance between them, which is 0.5 to the power of 2. Pull out your calculators and calculate this for me to find out what the answer is. All right, where's my calculator? Somewhere right here. Okay, let's do the calculation. I advise you to try doing the calculations because sometimes people make mistakes with the powers and the multiplication part and the signs, so that you can be confident in an exam to be able to find the required answers. So 9 times 10 to the power of 9 times 3 times 10 to the power of negative 6, okay, times 4 times 10 to the power of negative 6. Okay, divided by 0.5 squared. All right, you must come up with a final answer that's equal to 0.432 newtons. All right, 0.432 newtons. Now the question says, state the nature of the force. We are dealing with a negative 4 times 10 to the power of 4 and a positive 3 times 10. What happens between a positive charge and a negative charge? There is going to be an attraction. Negative and positive would attract each other. All right, so this is an attractive it will be an attractive force. All right, so we are done with that question. Let's move on and find out what other questions come into play when we are looking at electrostatics. Now, forces, as we have learned before in our introduction of vectors and scalars, they can be collinear, which means forces can work in the same line. When we have collinear forces, like for example, forces that are operating on the same line, we can be able or must be able to determine the resultant force. Look at this question. Although it's talking about electrostatic force, that same force we can be able to relate it to forces because it's a vector. A force is a vector, all right? And we can calculate the net force. So it says 3 charges Q1, Q2, and Q3 are placed at a distance from a charge Q4, as shown below. All right? Q1 and Q2 are 4.4 millimeters away from each other. Q2 and Q3 are 5 millimeters away from each other. Q2, 3 and Q4 are 2 centimeters from each other in this case. Q1 is equal to 6 coulombs, Q2 is 2 coulombs, and Q3 4 coulombs, and Q4 is equal to 1 coulomb. Determine the net force experienced by Q3, as a result of the forces due to their charges. All right? So, what do you think is the first thing that we should do if we are talking about forces? Think about it. In answering most of our questions in physics, especially that involve calculation, we must be able to have a picture of how the situation looks, so that from the picture we can extract information for the calculation. So let's talk about this example number 2. In example number 2, I must come up with a force diagram or a free body diagram that's showing what's happening at this instance. I have got Q3 right here, represented by this black dot, or this blue dot in this instance. All right, that's Q3. Between Q3 and Q4, there is going to be a force. All right, that's a force of 3 on 4. All right, and then we know that Q1 is further away. Let's put it a little bit longer, where we now have the force that exists between Q3 and Q1, and also a force that exists between Q2 and Q1. Now that we got an example or a picture of what is happening within this particular situation, we can express this in form of an equation. And so our equation is going to be simply F net to calculate the net force is equal to, if I choose the right to be positive, F3, 4 plus F minus, because this is in the opposite direction now, 1, 3 plus minus F 1, 2. Okay, so that will be my F net. Now, what is the challenge that I have now? Is to find the constituencies, the components, these forces that are operating, so that I can determine the resultant force. I can determine the resulting force due to the charges Q1, Q2, and Q4 on Q3. All right, let's start with F3 on 4. We know that our formula says, okay, Q3 multiplied by Q4 over the distance squared will give us that value. Our K is 9 times 10 to the power of 9 multiplied by the value of Q3, which is equal to 4 multiplied by Q4, which is equal to 1, divided by the distance between them is 2 centimeters. So what am I going to do? I'm going to convert that 2 centimeters into meters. How do we convert centimeters to meters? We divide by 100. 2 over 100, and this is squared. Pull out your calculator and calculate that with me. That's 4 multiplied by 1 times 9 times 10 to the power 9 divided by 2 over 100 squared. Let's see if you come up with the answer that I have here. The answer I have here is 9 times 10 to the power of 5 newtons. 9 times 10 to the power of 5 newtons. Okay? So that's F3 on 4. Let's move on. F1, 3. Okay? K, Q1, Q3. Right? You got the rhythm now. All right? Let's find out what's the over R squared again. 9 times 10 to the power of 9 multiplied by Q1 is equal to 6. Q3, we know Q3 is equal to 4 coulombs divided by the distance between them. Now the distance between them is 5 plus 4. 5 plus 4 gives us 9 millimeters. If we are going to change millimeters to meters, we are dividing by 1000 or multiplying by 10 to the power negative 3 is going to be equal to, pull out your calculators quickly and do the calculation for me. Find the answer there. All right, your answer should be 2.67 times 10 to the power of 3 newtons. Okay, let's follow suit. F1 is done, so we are moving on to F2. 3, okay, Q1, 2, Q3 over R squared. 9 times 10 to the power of 9, you got the rhythm, multiplied by the distance. I'm just checking now. Q2 is 2, and the distance is 5 millimeters. 2 times 4 over 5 millimeters into meters divided again by 1,000 all squared, and our answer is equivalent to 2.88 times 10 to the power of 3 newtons. Now that we've found the different forces that are acting on Q3, what do you think we have to do in order to find now the F net? What are we going to do? Think about it. Look at what we have just done. Yes, we are going to add them up together to calculate the F net. So F net, as we stated earlier on, is equal to 9 multiplied by 10 to the power of 5, right? In this case, minus 2,67 times 10 to the power of 3 minus 2,88 times 10 to the power of 3. Okay, so what are we doing? We are subtracting the ones that are going in the opposite direction. In this instance, our answer is 894,000 450 newtons. You can check my answer to see if it is right. Add those up. Okay, you can pause the video and add them up and see if you come up with the same answer as me. Now that the vector sum is positive, what do you think will be the direction of the net force? Positive direction. We had chosen the positive direction to be the right direction. So our net force is 894,450 newtons to the right. Okay, so that's done for collinear forces. What has this question allowed us to do? It has allowed us to understand a diagram that's showing forces that are collinear in form of a force diagram, free body diagram in this instance, and be able to find the net force, and given us quite extensive practice on calculating the electrostatic force. All right, now if they are not collinear, what are they? What happens if forces sometimes are not collinear? How do they occur? Like, for example, what we call non-collinear forces, forces that are acting at an angle to each other. Here's another example. Let's clear the board here and add another example of forces that are now not collinear. Let's call it example 3. I'm sure you're picking up the trend here of how we come up with these solutions. So example 3 is saying consider the charges that are placed on a Cartesian plane and these charges are shown as follows: charge A, charge B, charge C. Charge A is 20 millimeters from B upwards, and charge C is on the same horizontal position but 30 millimeters away from charge B. A, B, and C have 2 coulomb charge each, and the line BC and AB are at a right angle to each other. When charges are at a right angle, what do we know? They are 90 degrees to each other, right? That's what a right angle simply means, 90 degrees to each other. The question says calculate the net force due to the charges. So what am I looking for? I'm looking for the net force. So let's call it example 3.1. Okay, and calculate the F net. In order for us to successfully calculate the net force, as I always say, come up with a diagram that is showing you what is happening. So I've got my free body diagram here that shows me that there is A up there, there are all 2 coulombs positive, and there is B right here, and there is C right here. It is not to scale, but it's just a sketch to show me and help me in my calculation. All right. Now, if I want to find the net force, there are different ways I can think about it. Net force, I can say it will be found by this particular force that goes up from here to there. All right. Or I can put this one there and still come up with the same net force. But what I need is a formula, right? So I have to write out a formula that demonstrates what I need to use to find the net force. And my formula that I can use at this instance is one that says, because it's at a right angle, all right, F net squared. You would realize that this is a very common equation. Pythagoras theorem is equal to force BA squared, right, plus force BC squared. All right? That's how I'm going to come up with the value of the F net. So, how am I going to find BA? How am I going to find FB in order to come up with the net force? The same rigmarole has to come into action now. I have to find the value of FBA, and my FBA is going to be equal to K multiplied by QB multiplied by QA divided by the distance between them squared. So what's my K? 9 times 10 to the power of 9. What's my QB? Times 2. QA times 2. The distance between A and B is 20. So 20 millimeters. I can say 20 times 10 to the power negative 3 because they are 1,000 millimeters in a meter, all squared. What is my final answer? Once again, with my calculator, I am going to find the value of 9 multiplied by 10 to the power of 9. This is good practice for your calculator. You must be a good friend with your calculator because you need it to get to the correct answer. Okay. Divided by 20 times 10 to the power of 3 all squared. Right? What do you get as your final answer there? To the power of negative 3 all squared. Your final answer is 9 times. Let me just check mine quickly. Okay, my calculation, something went wrong. 9 times 10 to the power of 9 multiplied by 2, multiplied by 2. okay, divided by 20 times 10 to the power of -3, all raised to the power of 2. Yes, okay, so I got 9 times 10 to the power of 13. I hope you got the same answer as me. If you did, well done. 9 times 10 to the power of 13 newtons. Let's move on to F, B, C. K, Q1, QB, right? QC over again R squared. K is 9 times 10 to the power of 9 times 2 divided by, what's the distance between them? Now the distance is 3. Okay? 30 times 10 to the power -3 all over. Okay. That's squared. Do the calculation also. If you are very diligent with your calculation, you must be getting 10 to the power of 13 multiplied by 4. Okay, that's the scientific notation. 4 times 10 to the power of 13 newtons. Now for us to find the F nets, how are we going to do it? We say that F net squared is equal to FB squared, 9 times 10 to the power of 13 squared plus 4 times 10 to the power of 13 also squared. And to get F net, you obviously are finding the square roots of both sides. This becomes a simple mathematical calculation where you got, or should get, 9,85 times 10 to the power of 13 newtons. All right? The question then says the direction, calculate the direction of the net force. So in order for us to calculate the direction, I want you to remember, always we use the tangent, all right, of the y and y components over x component, right? In this case, our y component is this one, and our x component is that one, all right? So tan theta is equal to 9 times 10 to the power of 13 divided by 4 times 10 to the power of 13. Your mathematics will tell you these two are going to cancel. So 9 over 4. So in order to find theta, your maths teacher would have told you find arctan 9 over 4. You must be familiar with using your calculator to find arctan, which is second function tan 9 over 4. Try it on your own. The answer you should be getting is 66,04 degrees to 2 decimal places. 66,04 degrees, right, to 2 decimal places. That is the direction of the net force. So it will be 9.85 times 10 to the power 13 newtons. It's 66,04 degrees. All right. Those were some simple examples that we looked at. Let's look at some past exam questions quickly. This is DBE November 2005. It says two charged spheres. So you got two charged spheres, one of a value 2q and another one q, respectively are placed at a distance r from each other. So let's look at a distance r from each other and give them a distance one from another of r. Okay. Right. And on an insulated stand, why insulated stand? So that they do not pass on their charges to the ground. All right. If the sphere of charge q experiences a force F to the east, so let's say that's q, and it experiences a force F to the east, and the sphere 2q, all right, will experience a force of, remember that they experience exactly the same force because they are the same in their signs, both positive, they will repel each other. So the same force will be experienced but opposites in direction. So which direction do you think it will happen? This force was in the easterly direction. What do you think Q or 2Q would experience? It would experience F also, but to the west. All right, that's in the opposite direction. Good. All right, let's move on to another one. This is a longer question. Let's pick it. The top part is not that clear. It is just simply showing you two spheres. One of them is dangling. All right, let me just read it off the laptop here. And it says that all right, you got two spheres, P and R, okay? And there is a string that's attaching to P. Okay, let's just read the top part. A very small graphite coated sphere P is rubbed with a cloth. It is found that the sphere requires or acquires a charge of plus 0.5 microcoulomb. Calculate the number of electrons removed from the sphere during the charging process. So what's happening? It's been charged, all right? The number of electrons for 7.1, all right, you know number of charge at the back of your question paper is an equation that says Q, N is equal to Q divided by E. Charge over electrons, so the number of electrons. So we know that the value that we are given here of Q is 0.5 microcoulombs, 0.5 multiplied by 10 to the power negative 6, and then the charge of an electron is equivalent to, it's also found at the back of your question paper, the charge of an electron is equivalent to 1.6 times 10 to the power negative 19, 1.6 times 10 to the power of negative 19. All right, if you divide the two, you will get 3.13 times 10 to the power of 12 electrons. 3.13 times 10 to the power of 12 electrons. Excellent. All right, 7.3 requires us to state Coulomb's law in words. We've stated Coulomb's law already. We know what Coulomb's law states. Rewind the video. You will find out what Coulomb's law states. That says that there is an electrostatic force that exists between two objects, and that electrostatic force is directly proportional to the magnitude the product of the magnitude of the charges and inversely proportional to the square of the distances between them. All right, what is the magnitude of the tension in the string? Once again, we need to come up with a diagram that shows us what's happening here. We got tension in the string going up. We got a force R towards R, and we got the weight. All right? Simply, our calculation of the tension can be found by considering that if we consider the force exerted in this direction, right? That force, let's call it force E, is equal to K Q1 over Q2 over R squared. And the value of K, as we know, is 9 times 10 to the power of 9 times the value of Q1, which is 9 times 10, 0,5 times 10 to the power of negative 6, 0,5 times 10 to the power of negative 6, and the other charge is 0,9 times 10 to the power of negative 6 divided by the distance between them, 20 centimeters. So 20 times 10 to the power negative 2 all squared. All right? This is the force that's working in this direction. Okay? If I am to resolve T in that direction at an angle of 7 degrees, you can agree with me that T resolved downwards will be T sine of theta. In other words, it will be equal to Fe, my Fe that I am calculating here, right? So I am saying that this Fe is equal to T sine of theta. So to solve for the value of T, theta which is 7 degrees, okay? To solve for the value of T, I have to multiply by sine 7 degrees across. Okay, you can be able to solve this equation quickly, finding the value of T, and I am sure you can get the value of T to be equal to 0,83 newtons. Think about it, look at it, and you will realize how easy it is to find the tensional force, because the tensional force, if this thing is stationary, is going to be equal to the only force that's working, which is as a result of electrostatics. Well, that's been it for today. I hope you have picked a few nuggets. Keep on working at it and looking at a few examples. From me, your man Chibs, it's ciao.